Hello everyone, welcome to the Internship Studios session on AWS Route 53. It is a domain name system service provided by Amazon Web Services. So, directly jumping into the overview of DNS first, we need to understand what the definition of DNS is. DNS or domain name system is a hierarchical and decentralized system that translates human readable domain names into the IP addresses. So computers and network devices communicate using IP addresses has been already, which are numerical labels assigned to each device on a network. However, for humans, remembering and using IP addresses for websites or other services can be very challenging. So in our current times, we can see DNS, which is domain name system, has a fundamental technology that plays a very crucial role in enabling the smooth functioning of the internet. So at its core, DNS serves as a decentralized and distributed system that translates human readable domain names into machine readable IP addresses, facilitating the identification of devices on a network. So you can imagine navigating the internet without DNS. So it would be like trying to find a friend's house in a new city without a street address. So instead of remembering a complex sequence of numbers, for example IP addresses for each website, we can use easy to remember domain names like www.example.com. So example may be www.google.com for Google. So you can't remember the IP address of Google every time, right? So similarly, it's easy for humans to remember the names. So in a similar fashion, DNS acts as a global directory service, providing a way to map these user-friendly domain names to the actual numerical addresses that computers use to communicate over the internet. So this is about the overview of the DNS. So again, as you can see, DNS acts as a directory that helps users access websites and other resources using domain names such as www.example.com instead of numerical IP addresses like 192.168.1.1. So when you type a domain name into a web browser, your device queries DNS servers to find the corresponding IP address for that domain. So for example, we have a directory like nature of DNS where it is organized in a hierarchical structure. So there are some components like local DNS resolvers, which are often provided by the internet service providers, which serve as the initial contact point. So these resolvers, like neighborhood directories, either provide the required information directly or guide the inquiry through a series of hierarchical servers, including root DNS servers, top level domain servers, and authoritative name servers. So we'll see what these servers are in our next slides. So first we'll understand what the DNS system is organized into as a hierarchical structure. So it says it includes different types of DNS servers such as root DNS servers. So these servers are at the top of the hierarchy and provide information about the top level domain servers. Next we have the top level domain servers. So these servers manage domain names associated with specific extensions like .com, .org, .net, .etc. Authoritative DNS servers. So these servers store specific domain records providing information about IP addresses, mail servers, and other details for a given domain. Next, we have the recursive DNS servers. So these servers perform the actual work of translating domain names into IP addresses. So when you make a DNS query, your computer typically contacts a recursive DNS server to find the IP address. So we'll just simplify each one in an easy manner. So since we already know the DNS system is organized in a hierarchical structure, so the root DNS server is at the very top of this hierarchy. So think of it as the ultimate reference point in the global address book. So the root DNS server doesn't have specific information about every domain on the internet. Instead, it holds crucial information about the authoritative DNS servers for each top level domain. So how it works is, first we have the user request. So you type a domain name into your browser, for example www.flipkart.com. So what it does is it starts initiating a DNS lookup. So next is the local DNS resolver. So what your computer does is it first checks with a local DNS resolver, usually provided by the internet service provider. So we have Geo and Airtel service providers, right? If the resolver has the required information in its cache, it provides the IP address directly. If not, then it will move it to the next step. So the next step what we have is the root DNS server. So the local server contacts the root DNS server. So the root DNS server doesn't know the IP address for the specific domain, but directs the resolver to the TLD server responsible for the domain's extension. For example, like .com, .organization, etc. So this TLD server, what this does is the resolver guided by the root DNS server, it contacts the TLD server associated with the domain's extension. For example, if the domain is www.example.com, the TLD server for .com is queried. At last we have this authoritative name server. So the TLD server then points the resolver to the authoritative name server for the specific domain, in our case example.com. The authoritative name server has the most up-to-date information about the domain, including its IP address. So the IP address retrieval, what how it happens is the authoritative name server finally provides the IP address to the resolver, which can then pass it to your computer. So your device can now connect to the desired website using the obtained IP address. So in essence, the root DNS server plays a very key role in maintaining the integrity and efficiency of the DNS system by helping to route requests to the appropriate TLD servers, facilitating the translation of human readable domain names into the numerical addresses essential for internet communication. So this is about the types of hierarchical structure. So next is how DNS works. So we'll understand from the flow. This is an example of the Cloudflare which I have taken. So we'll break down the DNS resolution process step by step. So the first step is the from the client side what will happen is local DNS resolver. So when you enter a domain name, your device first checks the local DNS resolver. This resolver, often provided by internet service provider, maintains a cache of recently addressed or accessed domain names and their corresponding IP address. So if the required information is in the cache and still valid based on time to live or time to live, the resolver can provide the IP address directly, saving time and resources. So next what we have is the DNS route name server. So if the local resolver doesn't have the required information, it contacts the root DNS server. So the root DNS server is a crucial component at top of the sorry of the DNS hierarchy. However, it doesn't have details about specific domains. Instead, it directs the resolver to the appropriate TLD server based on the domain's extension. So next we have the DNS TLD name server. So following the root DNS server's guidance, so what the resolver does is it contacts the TLD server associated with the domain's extension again. So it may be .com or .organization or .net. So these TLD servers have information about the authoritative name servers for each domain within their domain extension. So next we have the cloudflare.com authoritative name server. So here what happens is the TLD server directs the resolver to the authoritative name server for the specific domain. So this authoritative name server is the ultimate authority for that domain and contains the most current information about the domain, including its IP address. So finally what happens is the IP address retrieval is happening. So the authoritative name server provides the IP address to the resolver, which then caches this information for future use. So the resolver passes the IP address to a device, allowing it to establish a connection with the desired website. So the IP address is crucial for the actual data exchange that happens when you visit a website, as devices communicate using these numerical addresses. So there are two important components that we come across in DNS. One would be the time to live, in short as TTL, and caching. So DNS records usually have a time to live value or a TTL value, which determines how long the information is considered valid. So after the TTL expires, the resolver needs to perform a new DNS lookup to ensure it has the latest IP address. So caching is a crucial aspect as well of DNS, as it helps reduce the load on DNS servers and speeds up the resolution process. So in everyday terms, we can see that think of DNS as a phone book for the internet. So when you want to call a friend, you don't need to remember their phone number. So phone number we can say as a IP address. So you simply look up their name in our case domain name in your phone book. So phone book is like a DNS. So the phone book is organized hierarchically, starting with the global directory. Global directory means the root DNS server that guides you to the right regional directory, which is the TLD server, eventually leading to the specific entry for your friend, which is the authoritative name server. So in summary, DNS is the backbone of the internet's user-friendly nature. It seamlessly translates human-readable domain names into machine-readable IP addresses. So this is how at a high level the DNS works. So this is again a nice pictorial representation of how DNS works. It just takes on with the previous concept as well. So let us take some analogy to understand DNS even better. So to make things simple, we'll use some relatable examples here. So imagine you want to visit a website, let's say www.example.com. So you type this domain name into your web browser in your laptop or your phone and hit enter. Okay. So this is the first user input. So what happens here is your computer checks with its local DNS resolver, which is like a helper that knows some addresses already. So it's a bit like your computer asking, do I already know how to find www.example.com? So if you recently visited www.example.com, the resolver might already have the IP address in its memory. So it tells your computer where to go without asking anyone else. So in the next step, we have the root DNS server. So if the local resolver doesn't know the IP address, it goes to the big boss of DNS, the root DNS server. So this server doesn't know the address either, but it can tell your computer who to ask next. For example, it's like asking the manager of a big mall for directions to a specific store. So the mall manager doesn't know where every store is, but they can guide you to the right section. So in the next step, we come across the top level domain server, which is also spelled as TLD name server. So your computer follows the root DNS server's advice and asks at the TLD server. The TLD is like the category of the website's address, such as .com or .org. So example, if www.example.com is like a shop in a mall, the TLD server is the directory for all the shops in that category. So like a directory for all .com websites. So finally we have the authoritative name server. So the TLD server guides your computer to the authoritative name server for www.example.com. So this server knows the actual address of your computer is looking for. So this was about the explanation. So next we have the DNS hierarchy. So as we already saw, first thing is the root DNS server. So this is the overview of the DNS hierarchy. So we can see that the root domain is denoted by a dot, and it doesn't represent a specific domain name but rather serves as the starting point for all DNS queries. So the root domain is maintained by a set of authoritative root DNS servers. So imagine the root domain has the first page of an enormous global directory containing information about the top level domains. Next we have the top level domains. So we can see .com, .edu, .gov, .mil, .org, .net, .in. So below are the root domain are the top level domains. So which are the domain extensions like .com, .org, .net, etc. It can also include the country codes like .us, .in, .uk. So TLDs are managed by specific organizations called domain registries. So for example, in the analogy of a global directory, we can say TLDs are like different sections or categories in the directory, such as business, organization, or country sections. So similarly, we can also have the authoritative name servers. So these are responsible for holding and providing information about the domain. So we have this novel UCLA. So we can have novel.com, ucla.edu, whitehouse.gov. Similarly, everything is matched up accordingly. So that was a bit basics about AWS DNS. So coming to AWS Route 53. So we'll read out the definition first. So Amazon Route 53 is a scalable and highly available domain name system DNS web service provided by the Amazon Web Services. So it is designed to route end user requests to endpoints like AWS resources such as EC2 instances, elastic load balancers, or S3 buckets by translating human readable domain names into IP addresses. So at a high level, we can say Route 53 is a domain name system service provided by AWS. So we'll go into the salient features. The initial one is the domain registration. So Route 53 allows you to register domain names directly through the service. You can choose from a variety of top level domains and manage your domain registrations alongside your other AWS resources. So the first and foremost benefit is domain registration. Actually, AWS has a set of domain names already in their portfolio, which you can use them for annual or multiple years subscription based. Next is the DNS service. So Route 53 provides a reliable and scalable DNS service. It can be used to create and manage public and private hosted zones which contain information about how you want to route traffic for a domain and its subdomains. So in Amazon Route 53, a hosted zone is a container for DNS records and it serves as the authoritative DNS database for a particular domain such as example.com. Hosted zones help manage how DNS requests for a domain are resolved. So we have two types as we saw, public hosted zones and private hosted zones. So a public hosted zone, it is a container for DNS records that is publicly accessible over the internet. So it is used to manage the domain's public DNS records, making them available to the general public. So typically these use cases are these zones are typically used for domains that are publicly accessible on the internet, such as websites or web applications that are meant to be accessible to anyone. So example is if you have a website www.example.com that you want the public to access, you would create a public hosted zone for example.com in Route 53. So this hosted zone contains DNS records that direct traffic to your web servers. On the other hand, a private hosted zone is a container for DNS records that is associated with the Amazon Virtual Private Cloud and is not publicly accessible. So it is used to manage domain names and their associated records within a private network. So one good use case is if you want to resolve domain names privately within your VPCs and do not want these records to be publicly accessible on the internet. So the key differences are public hosted zones are accessible over the internet and can be queried by anyone. Meanwhile, private hosted zones are only accessible within the specified Amazon VPCs and are not visible to or queryable from the public internet. Also, public hosted zones are used for domains that need to be publicly accessible like websites. On the other hand, private hosted zones are used for internal domain resolution within specific VPCs. Public hosted zones have a wider visibility to the public, including search engines and other DNS resolvers, whereas private hosted zones are not visible outside the specified VPCs, ensuring privacy to internal domain names. So this is about the DNS service capabilities. Next is the traffic management. So Route 53 offers traffic management features such as DNS based load balancing or simple routing, which allows you to distribute traffic across multiple endpoints based on routing policies. So you can see that traffic management refers to the ability to control and distribute incoming DNS requests among different resources or endpoints based on various criteria. So there are kind of routing policies. First one is the simple routing, which is here. So this policy, what it does is it allows us to associate a single resource record set with a domain. So it's suitable for basic setups with a single endpoint. So example scenario we can take that. Let's say we have two instances of your web application running in different AWS regions, and you want to distribute traffic between them based on the geographic location of the users. So we can achieve this using Route 53. First is we can create latency based routing. So we can set up a latency based routing policy in Route 53. We can create a resource record sets for each instance and associate them with the respective AWS regions. Also, we have the capability to define the health checks for both the instances to monitor the availability. Also, we have the geolocation based traffic management. We also have the weighted routing for testing. So if you want to perform A/B testing, which is a kind of testing employed in the DevOps environments, you can use weighted routing to gradually shift a percentage of traffic to a new version of your application running on one of the instances. So by combining these routing policies, we have a powerful mechanism to manage and optimize traffic distribution in Route 53. So the flexibility provided by these policies allows you to tailor your traffic management strategy based on your specific requirements, whether it's for high availability, performance optimization, or controlled release of new features. So next we have the health checks. So we already saw health checks we can configure with the help of Route 53. Next is the domain name system security extensions. So Route 53 supports DNSSEC, which adds an additional layer of security to DNS responses by signing them with cryptographic signatures. So DNSSEC is a suite of extensions to the domain name system protocol that adds an extra layer of security to the domain name lookup process. So the primary purpose of DNSSEC is to protect against certain types of cyber attacks that can compromise the integrity of DNS data. So first one is the data integrity. So one of the primary objectives of DNSSEC is to ensure the integrity of DNS data. Next is like it can use digital signatures to sign the DNS data. Next is DNSSEC also establishes a chain of trust from the root DNS servers to the authoritative name servers for a specific domain. It also has some key signing and zone signing keys. We may call KSK and ZSK. So you may type in the internet to learn more about it. Next is also like there are some protection against cache poisoning. So DNSSEC helps protect against cache poisoning attacks. So when an attacker inserts false information into the cache of a DNS resolver with DNSSEC, the resolver can verify the authenticity of DNS responses and reject any tampered data. So what end of the day what it does is it enhances the security of the DNS infrastructure by providing a mechanism to verify the authenticity and integrity of the DNS data. While it doesn't address all security concerns related to DNS, it is a significant step in mitigating certain types of attacks and ensuring a more secure and trustworthy DNS resolution process. Another component is it has global anycast network. So Route 53 uses a global network of DNS servers to provide low latency DNS responses. So this anycast network helps in reducing the time it takes for DNS queries to be resolved, enhancing the performance of your applications. So also it is backed by a global anycast network. So your DNS resolution steps will be super smooth here. Next we have integration with AWS services. So since it is already native AWS service, so it will easily integrate with AWS S3 buckets, CloudFront distributions and more. Maybe even with EC2, Fargate or EKS, which is a Kubernetes based service. So now we'll understand this is a generic architecture diagram about how AWS Route 53 works. So we have this small integrated setup where we have this Route 53 with health checks, CloudWatch alarms, CloudWatch log groups, and we have three EC2 instances running in different availability zones. So what this integrated setup combines is it uses AWS Route 53 for DNS management and health checks, CloudWatch for monitoring and alarming, EC2 instances running your application. CloudWatch agent on EC2 instance facilitates the collection of custom metrics and logs, allowing for a comprehensive monitoring solution. So the use of health checks in Route 53 enables automatic failover and DNS adjustments based on the health of your resources, contributing to improved application availability and reliability. So I'll just show you, since I don't have any domain name handy or registered upon my name. So what I will do is I'll just walk you through the console about the Route 53 features and functionalities. So this is what we have about the Route 53. In the left side we have the dashboard where we have the DNS management, the traffic management, the domain registration. So since I don't have any domains, it says error. We also have the capability of availability monitoring. So we'll just check. We have one created by default by someone since it's a cloud playground. So I can see, I'll extend the name. We have one created by the cloud playground, which is it says some real hands-on labs.net. So the type is public and it's created by Route 53. So the record count is 2 and it's something called, so it says hosted. So hosted is, so yeah, we'll leave, it's not important. And next we have the health checks. So it says welcome to Route 53 health checks. So health checks monitor the health and performance of your application servers or endpoints from a network of health checkers in locations around the world. So you can specify either a domain name or an IP address and a port to create HTTP, HTTPS and TCP health checks that check the health of the endpoint. So we also have the availability and performance monitoring and the DNS failure. So in case if there is some outage issues, then you can do a successful failover. So also we have the domains, so you can see all the registered domains if there are any on your name. Since I don't have any, there are no domains to display. Also there are some couple of resolvers. We can also set the traffic flow with adjusting the traffic policies as well. So this is it about an overview in the console. So we'll just go ahead and see with the best practices. So you want to play around, just have a domain name handy with you and you can play around with different features available. So we'll just see the best practices. It says use alias records for AWS resources. So what it says is when pointing to AWS resources like Elastic Load Balancers, CloudFront distributions, or S3 buckets, you can use alias records instead of traditional CNAME records. So alias records provide seamless integration and are more efficient. So next one is implement health checks. So we can set up health checks for your endpoints to monitor the health of your resources. So configure failover and routing policies based on health check results to ensure high availability. So next is the multi-region and multi-ELB setups. So for applications hosted across multiple AWS regions, we can use latency based routing to direct traffic to the region with the lowest latency. So we can implement DNS failover as well, uh, as we already saw in the console. We can leverage traffic flow for advanced routing policies. So leveraging traffic flow in Route 53 to create advanced routing configurations with visual representations. This allows for more sophisticated traffic management and conditional routing. So you can also enable DNS logging for if you want to troubleshoot any resolving related errors. Next we have secure domain with DNS sec. So we can enable DNS security extensions to enhance the security of our DNS infrastructure. So it helps prevent attacks like DNS spoofing and cache poisoning. So also we have monitor route 53 metrics. So we also have the ability to monitor using the metrics using CloudWatch or cloud logs provided by AWS. Next we have the optimized TTL values, and we can use Route 53 resolver endpoints. We can regularly review and clean up. So it's a best practice to always see what resources are unused in AWS. So we can go ahead and delete any unused name records or any domains being laid up as it is in the console or account. So next is we can back up our DNS configurations. So it's always a good practice. We have backups of all the DNS configurations that we have done in our AWS account related to our Route 53. Also, it's also good practice to maintain a thorough documentation for your DNS configurations, because we should use meaningful tags for hosted zones. This helps in tracking and managing resources effectively, especially in environments with multiple domains. So this is about the important best practices which will be asked in maybe solution architect or developer associate exams. So it's better to be aware of all these best practices. So yeah, that was all about the session regarding Route 53. So in summary, we just had an overview of Route 53, how the DNS works in the back end, how AWS Route 53 works, and just saw the best practices of and features of the AWS Route 53. So in the next session, we'll be discussing on AWS load balancers, and also we'll be having the hands-on session as well. So thank you for attending the session and see you on the next session. Bye everyone.